Hey guys, this is Jagan signing up from Tech Tutor. So in this podcast, we are going to be discussing about singly linked list reversal. So we are going to use C++. So let's begin with main CPP. So let's include IO stream. Let's use the namespace std and let's start with our node structure. It's going to be a simple structure, so it just has a data and of course a next pointer. Okay, so let's begin with our class list and private data, and let's begin with head and tail pointer. Okay, and of course we need to declare our constructors, destructors. Okay, and let's also add some add function to insert nodes into the list, and let's implement a print function. Let's also implement our reverse procedure. Okay, that's it. So let's begin with our constructor. In the constructor, we will ensure that head and tail pointers are initialized to null. That's it. And I'm going to be postponing the implementation of destructor. So I'm going to say fix me delete the list here. Okay, otherwise it will lead to memory leaks. Okay, let's begin with our add node. Okay, int data. Okay, so we will declare a new node pointer, node new node, which is equals new node. Okay, so let's assign data that is supplied to the function, and we'll also ensure that new node's next pointer is pointing to null. So at this point we have created a node, new node, and which also is assigned with the value that is supplied to the function as data, and its next pointer is pointing to null. So all we got to do is we need to add this new node into the appropriate position. So the way the linked list works is always we'll be inserting or adding nodes at the end of the list. So we're going to check if we already got some values entries into the list. So we can check that by checking if the head node is null. If the head node is null, so that indicates this is the very first node. Okay, so in that case we can say head, and both head and tail are pointing to new node. Otherwise we will say that tail.next is nothing but new node, which means we are adding the new node at the end of the list. And of course we need to move our tail node to the last node. Last node is nothing but new node. So we are done. That's it. And at this point let's write the print function. Okay, and if the list happens to be empty, our head pointer will be empty, null, right? So we have nothing to print. Otherwise we will initialize current equals head, and then we'll navigate, while null not equal to current. So let's print the current data. We'll also give some tab space, and let's navigate our current pointer to the next node. Okay, we are done, and let's give a new line. Let's start with a new line as well. Okay, that's it. And now let's implement our reverse function. So we are going to be taking a very simple approach, iterative approach, and as well as it is going to be an efficient one, right? So let's declare a previous node which happens to be null, and current node which points to our head node, and a next node which points to head's next node. So in case the head pointer happens to be null, right, the line number 61 will lead to crash. So let's add some sanity check here. If null happens to be, if the head pointer happens to be null, or if there is only one node in the list, right, so we don't have to reverse anything. Otherwise we will go ahead with this procedure. Now we are going to check if null not equals to current node, so we will proceed with the reversal procedure. Okay, so the previous, so current node's next node is going to be previous node. So at this point we have reversed one node. Okay, so now all we got to do is we got to slide all these three node pointers to the next position. Okay, so we're going to do that with, we're going to begin that with previous node comes to the position of current node. Okay, and the current node is going to move to where next node is pointing, and next node is going to move to next nodes dot next. Of course we need to check for null. If next node not equal to null, then we are safe to do this. Okay, we are done. That's it. So at this point we need to recompute the head and tail. So the tail pointer is nothing but head pointer after reversing, and the head pointer is going to be previous node. That's it. So let's call this in the main and see how it goes. Let's create the list. Okay, and so let's print. Okay, before printing we need to add some values. So list add node 10. Let's copy this and then paste. So let's add some 5 entries. So this is going to be 20, this is going to be 30, this is going to be 40, and 50. Okay, we are good. So let's print list entries before reversing. Okay, and list print. Okay, and now let's reverse the list, and let's try to print the list again. Okay, so this time it's going to be after reversing. Right, we are good. So let's return 0 to indicate a success. So let's save and compile and see how it goes. Okay, line number 33. Okay, it is supposed to be new node. Okay, we are good. That's it. So list before reversing is 10, 20, 30, 40 and 50. List entries after reversing is 50, 40, 30 and 20 and 10. So that's it, we are good. So now let's revisit the code and see. Let's try to understand this. Okay, so let's use the board. So we declared a node structure, and then we began with list. So we have declared head and tail pointers, and we have declared destructor, constructors, add node, print, reverse, and everything. We are yet to fill up this. Okay, let's revisit this one. And over here, add node. Okay, so what this three lines are doing is actually we have allocated a new node. Okay, let's call this as new node, and whatever values are supplied, they will be assigned over here. So let's say we assume value 100 is applied, so 100 will be assigned here. And then we also wanted to ensure that this next node is pointing to null. So we are done with it. So at this point, we have a new node assigned with values, and its next pointer is pointing to null. Okay, now we need to add this new node to the list in the appropriate position, correct? So at this point, if the list is empty, and this is the very first node that is being added to the list, so the head pointer will be null. So in that case, we can point, so this is going to be our head node, and this is also going to be our tail node, right? We are done with it. Let's say the second time a new value is added, second time add node is added, called, right? So let's assume this time we are trying to add a value 200. Okay, so we are going to be creating, so at this point, this is no more our new node. So at this point, actually we are going to be calling this node as the new node. Okay, so assume this was invoked with add node 100. So now it is add node 200, right? Okay, so now we have allocated memory, and it looks like this. And at this point, number 200, value 200 is assigned. So we are done with this, right? And at this point, new node's next is made to null. So we are good. So now we need to add this new node into the list. Okay, so when we check if head node happens to be null, it is not null this time, because head node is pointing to this node. Okay, so it comes to the else part, and else part we are saying that tails next equals new node, right? So at this point, so this one we modify so that this points to this node. That's it. So now still our tail pointer is still pointing to the first node, right? So in this line we are moving this. So tail pointer is pointing to this one now. That's it. So this is how the new nodes are added into the list. So now let's try to understand the reverse procedure. Okay, so in case of reverse procedure, right, so if suppose we invoke this reverse on an empty list, so in that case head pointer is going to be pointing to null, right? Or if there is only one node, right, if there is only one node in the list, so in that case as well, so we will be simply returning. So these two possibilities are already handled. Now we have declared a previous node, current node, and next node. Okay, the previous node, if you notice, it is pointing to null, and current node, let's assume this list. Okay, so it is a 10, and then 20, and then a 30, and then we have a 40. Okay, this is our list. So this is our head node, this is nothing but the tail node. Okay, so where is our previous node pointing? The previous node is pointing over here. Okay, and at this point the current node is pointing here. Okay, now the next node is pointing here. Okay, that is essentially we have done here, right? Current node pointing to head, okay, and next node pointing to head dot next. So this is what we are doing now. So what we are doing is null while null not equal to current node. Okay, so current node dot next. Actually right now it is pointing to 20, so instead we are saying this link we are breaking, and then we are saying that this is pointing to, this is going to point to previous node, correct? The previous node is null at this point, so that's it. We have reversed one node. Okay, now all we got to do is we need to slide these three pointers one position. So the previous pointer is going to come over here, and this is going to go over here, and this is going to go over here. Okay, so that is what we have done here. Previous node comes here, this is previous, and the next node comes here. Okay, and the current, sorry, this is current node, and this is nothing but our next node. Okay, let me erase all this. Okay, now this is our next, and this is pointing to null at this point. Okay, now in the next iteration, correct, in the next iteration we will be checking this again. While null not equal to current node is not null, current node is actually pointing to 20. So now we are saying the current node's next pointer is going to be pointing to previous. So where is this going to point to? This is going to point to this node, correct? That's it, and this link is anyway broken. So now this is pointing to this one instead, right? So now from 20 it is reversed. 20 is pointing to 10, and 10 is pointing to null, right? That's it. Now this goes on like this. Now we need to slide this again, correct? So how, when we slide this, correct, the previous is going to come over here, current is going to come over here, and this will be our next node. So at this point we are going to say we are going to break this link, correct, and this is going to point to this node, okay, which is nothing but our previous node. Once we are done, we are going to be sliding all three. Okay, okay, so this becomes the previous, this becomes the previous, this becomes the current, and here goes our next. Okay, so at this point we are again checking if current is not equal to null. Current is actually pointing to tail node, which is not null, and we are going to break this link. We're going to break this link, correct, and this is going to in turn point to this node. Okay, and we are going to again slide this. So at this point the previous node comes over here, current node goes here, and next node is anyway null. So during the next iteration, when the current node is null, it's going to terminate. When it terminates, so all we got to do is we need to reverse these 2 pointers. So now, so the list is actually, the list looks like this, right? 40, 30, 20 and 10. Now we need to ensure 40 is pointed by head node and 10 is pointed by tail node. So how we can achieve that is, we are saying this is our tail. This is our tail node. This is the tail node. Okay. And this is going to be our head node. Because if you notice, when the loop terminates out of this loop, right? When the control comes out of this loop, the previous node is going to hold this position, correct? So it is safe to say this. So the best part about this, right? The best part about this algorithm is that if you notice, we are only taking order of n time complexity. This is the time complexity it takes. And the memory complexity is constant time because we are not using any additional memory. So which is actually good for a list problem. Thank you. Yeah. So if you like this video, you can subscribe so that you can get notified when I add new videos. Thank you.